So today, I've been trying to decide on how to approach today's lesson because we don't have a lot of objectives to cover. And so I think what we're going to do is we're going to do just a quick walkthrough on the To-Do app from yesterday, on the To-Do project. And then hopefully clear some of that up for you guys, because I know that was a struggle for a lot of people yesterday. So let's get started with that, and then we'll jump into what the rest of the day is going to look like. Okay, so I need to go to yesterday's lesson, yesterday's project. I'm going to pull this into Code Sandbox. All right. So we need to start up our own project, right? And we're going to right away add Redux. And we're going to add React Redux. Those are the two libraries we need. Okay, let's take a look at the project. So initialize it, we've done that. We have our directory, we've added Redux and React Redux. So we'll create a to-do list using React and Redux, use the movies project as a reference. So we're going to follow this general flow of steps right now. We're going to create our store, then we're going to create reducers for our store, then we're going to create our containers, and we'll talk a little bit more about what this is, because I know there's been a little bit of confusion behind this still. And then the action creators. All right, so let's just start by creating our store. So we're going to do that by, actually if you'd like to follow along and code alongside me, jump into Code Sandbox. I'll give you a quick minute to do that and add React Redux and Redux as dependencies. So again, if you'd like to follow along and do this alongside me, jump into Code Sandbox, start a new React project, and add React Redux and Redux as dependencies. I'll give you a quick second to do that. Okay, so we need to create our store. So we're going to import create store from Redux. And then we also know that we need to import provider from React Redux. All right, so let's wrap our app down here in the render, in React.render. Let's wrap this with the provider. Perfect. When we save that, it drops it down. Now we know that we need to pass our store that we're about to create to our provider component as a prop. So it's going to take a store prop, and we're going to pass it the store that we create right now. So let's create that. So to create the store, we use create store, woohoo! And we're going to pass in our reducer, but we don't have our reducer yet. So let's go in, let's create a folder and create our first reducer. So I'm going to create a new directory inside source, and I'm going to call this store. And I'm going to keep everything that's related to the store inside this store directory. So inside the store directory, I'm going to create another directory called actions. And then I'm going to create a second directory called reducers. All right, so we want to create a reducer, so we'll create an index.js file. And we will create our reducer. So when we come to our reducer file, there is something we need to keep in mind. And that's kind of the fundamental idea behind what a reducer is. So a reducer, if you remember when we looked at the dispatch function inside the Redux source files, we saw something like this. Current state equals reducer with current state passed in and an action passed in, right? So Redux is going to invoke our reducer that we create right here, and it's going to take in two things, and with those two things, it's going to return an object. Let's just close this for a minute. So this reducer is going to return an object, and that object needs to reflect exactly what our state is. We'll say that it has the same shape as our state. So when we're writing our reducer, we need to make sure that for every case in our switch statement, for every action that could possibly come in, we're going to update our current state, and we have to return an object that looks exactly the same as our state object. So keeping that in mind, let's create our initial state, and that way we know exactly what our reducer is supposed to return no matter what action we call. So we're going to have const initial state, and this is always an object. Our state is always an object. Excuse me, I'm going to take a quick drink. Okay, that's better. So in order to know what our initial state is, let's go back to the requirements. And we can see that our state tree is given to us right here. So we're going to have an object, which we have, and that object is going to have one property called to-dos, which is an array of these to-dos right here. Zoom in a little bit for you guys, sorry. So let's create our to-dos. And then just for testing purposes, we're going to just add this one to-do inside here. So we want to tab those in like that. It's probably, okay, let me save it like that. All right, so this is our initial state. This is what we want our state to always, always, always look like, no matter what action is called, is triggered, is dispatched. So no matter what action is dispatched, our reducer is going to get called, and it's going to return an object that looks like this. It's always going to have a to-dos property. It's always going to have an array. The array could be empty, or it could have objects inside it. And if it does have objects, they're always going to look like this. So this is important to keep in mind, that no matter what action comes through, we are always, always, always going to return an object that has the same shape as our state. So let's create our reducer. Let's see, export. Const. There we go. Then our reducer is always going to take in the current state and an action. So we pass in state, and we default this to our initial state. And then it's going to take in an action. So then we write a switch statement, and we're going to check the action type. And by default, we will return state. And when we do this, it's returning this right here the first time. And so we are returning an object that has the same shape as our initial state, because we're just returning initial state. Okay, so let's pause there. And let's see. Wouldn't you have to give it an ID to be able to select the to-do to delete it? Yes. Yep, we'll do that. Do we need to handle the input inside of the state object with an input text property or something? You can. We're actually going to talk about this exact thing today. And I'll show you the way that I would do it. And the way I would do it is not to handle input text inside our Redux. I'm going to handle input text in our component state. And there's an article, or there's a part of the Redux docs that I'm going to show you that talks about this when we get into our component and we get ready to implement our input text. Really good question, though. This means you're thinking about state the right way. Okay, cool. So we have a reducer. It is going to return, by default, this state right here. And I'll drop this in here for you guys in case you need to sync up with me at some point. So let's go back here. So we have created our store. Oh, we need to pass our reducer to our store. So let's do that. We're going to import to-do reducer from store/reducers. And we'll just pass that in right here. And then we're also going to pass in our Chrome DevTool thing right there. Too many, there we go. Okay. Cool, so we have our reducer, we have our store, and we've passed our store to the provider. So let's open this up in a new window, and let's check out what change that made on our application. Okay, we have this provider wrapper that's wrapped our app, and it has this store object passed to it as props, right? We passed store as props. So doing this right here created this object with a bunch of functions, a bunch of methods on it. Dispatch, get state, lifted store, replace, reduce, or subscribe. We've seen a few of these, and I think we understand a couple of these pretty well. We have not yet connected any of our components. So none of our components have access to our state yet. So let's look at the instructions. We've created our store, we've created our reducer. Now let's create our containers. So, oops. So let's look at what a container is one more time. If we can find it. Data flow. Okay, here we go. Presentational and container components. So this is an important thing to kind of wrap our minds around as we're building React applications. This is really how we think in React and Redux. So a container, when we see this name, container, and we're talking about Redux, what we're talking about is the component that we are going to have that subscribes to the Redux state. So a container just means it has, that inside that component we're going to import connect function, and we're going to connect this component to our Redux state. So that's all a container is. And this is a really good, I really, really like this table. So I'm going to drop this in our Slack channel as well. And I would encourage you guys to read up on this. And this is, I'm sure, a fantastic article. I don't know if I have read this one in particular, but it's recommended right here. So let me drop this in here for you guys. And looks like we've got a couple questions. Oh, Casey, I'll show you that in just a second. I created a store folder. You may not have, but I did. Patrick, we can have, yes, you will have multiple containers. The bigger and more complex your application gets, the more containers you'll have. And then let's actually look at one more graphic. If we can find a good one real quick. Let's see. I think this one's just fine. Well, one that's got a few more. We'll go with this one right here. Okay. So to explain this just a little bit more, out here we have our store with Redux, right? We have separated concerns. We're not handling app-wide data inside our components anymore. App-wide data is going to be managed inside our Redux store. So our Redux store, we can connect to our Redux store with the connect function inside of container components. So we'll say that this is our app.js, and it just kind of sits there. It gives us a place to wrap inside, or to put inside our provider, our router, et cetera, et cetera. This is kind of outside the component tree as a whole. So then our app is going to render our two container components. And these container components usually aren't going to render anything to the DOM. They're not presentational. Blah, 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 blah. Okay? Our container, what they do is they subscribe to the store, and they receive data through the connect function and through map state to props. Map state to props. So through the connect and through map state to props, our container components are subscribing to the data, which means since they're subscribing using store.subscribe, anytime a change happens here, these container components receive the updated state object. And then they take that data that they have received from the store and they pass it down to the presentational components as props. So all these blue lines are props, and all these blue components, all these children components are presentational components. Blah, blah. So this is the this is probably the way that you will see Redux used the most, where you have these big wrapping container components that don't actually render any headers, or we're not mapping through data and rendering lists of stuff. They leave all that presentational stuff to the children components. These container components are managing state and watching for changes from the store, from the Redux store. I will leave that there for you guys. There we go. And I'll send that picture to you guys. So let's go back. Now that we have a good idea of what container components, still on annotate. There we go. Now that we have a better idea of what container components are, let's build a container component for our to-dos. Where do we subscribe the container components to the store? That happens in the connect function. So when we bring in connect, the connect function does that for us. We don't have to worry about that connecting piece. But very good question. So by bringing in connect to our container components, we are essentially subscribing to the store. All right, so now in source, we're going to create a folder called components. And let's do a new file called todo container.js. All right, so inside here, we need to create our component. And this is going to be a class component. Okay, and then on this class component, we're going to have a state object. Remember, now that we know everything about constructor and how that works, I'm okay if you guys do this for your state inside a class component. So we're going to have some state inside here, and we're also going to connect this app to the store. Just return an empty div for now. So in order to connect this to the store, we have to import connect. From React Redux. Then we're going to export this component. And we're not going to export the component itself. We're going to export whatever connect returns to us here. So we're a little more familiar with this syntax now, thanks to this morning. This is a technique called currying, if you want to look it up. The first time that we invoke connect, we need to pass in a map state to props function, and then we're going to pass in our action creators inside this object. Then the second time is when we pass in todo container. So let's build map state to props. And this takes in state and returns an object. So what do we have on our state? Let's go back to our reducers. We have on our state object, we have a list of to-dos. So in here, I'm going to say to-dos is going to receive state.todos. Okay, perfect. So we've got our map state to props. We've got our component connected. And let's bring this into our app.js and render it so that we can go look at it in the React tools. So we will import todo container from, I'm going to change one thing real quick. I'm going to create a new directory called, a lot of times you'll see it called views. To keep it kind of straight for us, I'm going to call it containers. And I'm going to move todo container into containers. So you'll see you'll see a lot of projects that separate container components from presentational components this way. There we go. So this is a very common way that you'll see your file structure, your files structured. So we're going to import to-do container from containers. Oh, let's do / though. To-do container. And then we'll render that here. Okay, so let's go to our app. We've got our provider, we've got our app, and now we have this connect. HOC right here. So this should be giving us, through our map state to props, our to-dos array on our props. So to-do container has our to-do array. By the way, I don't know if you knew you could do this, but you can toggle Booleans inside the React tools. It's really cool. All right. So let's do, let's look at the next thing. So we've added our container. We've created our container. It's receiving our state. So let's create the action creators. Well, before we do that, we need to get our to-dos displayed and then an input so that we can even have any actions to run. So we'll get the HTML or the JSX set up so we have stuff on our screen to interact with, and then we'll take a quick break at that point. So in our components directory, we're going to create a file called todolist.js, and this is going to be a functional and presentational component that is going to display our stuff. All right. So we've got our to-do list function that we're exporting from this folder, and it's going to return a few things. Since it's going to return a few things, I'm going to import fragment from React and wrap the whole thing in fragment. Fragment. There we go. Okay. So first we're going to, we'll make an input, and then we will make an unordered list for our to-dos. Okay, so I need to get props.todos down to my to-do list here. In order to do that, we need to go into to-do container and import to-do list from, we go out of containers into components and into to-do list. And now we're going to render our to-do list. Okay, so we know that we have in our to-do container, we have props.todos. So we're going to pass those to-dos down from props.todos. Oh, this.props.todos, because this is a class. So we need this.props.todos. Perfect. Now we can go into to-do list, and we should have prop types down here, but for sake of time, we won't do prop types for this example. We're going to map, and we're going to pass in a to-do on each iteration, and we're going to render our to-do item. So we'll render an li. We'll give it a key of to-do.id, and we will say we'll render to-do. Let's look at our reducer, to-do.value. And it's saying we have an error. Props.todos. Oh, because we didn't name it props.todos, right? We named it to-dos list. Let's name it to-do list. Well, let's actually name it to-dos, because a list is a singular thing with a bunch of to-dos on it, but we're passing down. Oh yeah, we can name it to-do list because we are passing down a list of to-dos. Okay. So to-do list.map. There we go. Hey, there's our walk the dog. Awesome. So we have, we've got our to-do showing up here. Let's handle our input, and then we'll take a quick break. So at this point, I want to readdress that question we had about how we handle this part of our state versus these to-dos, which are handled in our Redux. So if we go to the Redux docs, and under FAQs, we see there's a section about organizing state. And there's a question called, do I put all my state in Redux? Should I ever use React's set state? So this is a really good question. And I know I saw this come up yesterday, and we had a question even during our lecture this morning about that was exactly this. Don't we put all of our state into Redux? Should we ever use React set state? Well, there's no right answer for this. Well, of course you would say that. Dang it. Some users prefer to keep every single piece of data in Redux. So if we wanted to, we could handle the input text inside Redux, and every time we type, it would invoke an action creator and go through our reducers, and our state would be updated. And then this component would update with the new character that we typed. So we could do that. And some users prefer to do that. And there's some reasons for that, and they list those here. So others prefer to keep non-critical or UI states such as, is this dropdown currently open, or such as input text inside a component's internal state. And then they say, with bold and italics, using local component state is fine. As a developer, it is your job to determine what kinds of state make up your application and where each piece of state should live. Find a balance that works for you and go with it. So the short answer to this question is you get to decide. Woohoo! But here's some common rules of thumb for determining what to put in Redux. Do other parts of the application care about this data? Do you need to be able to create further derived data based on this original data? So do you need to take in the original data and derive further data based on that? Then it may be a good idea to do that inside actions and reducers so that we know, so that we can be confident that it's always going to have the same result. Is the same data being used to drive multiple components? Is there a value to you in being able to restore this state to any given point in time through time travel debugging with our Redux tools? Do you want to cache the data, i.e. use what's in state if it's already there instead of re-requesting it? So, and then the rest of this isn't too important. There are a lot of other resources here that talk about it that you can look into to kind of create your own opinion on how to handle this situation. So I'm going to follow the common rules of thumb, and when we're looking at this input box, we have a choice. We can control this input box through Redux, or we can control it through our container just with local component state. Do other parts of our application care about our input text? Nope. Do we need to be able to create further data, derived data based on this original data? We do not. Is the same data being used to drive multiple components? It is not. Is there value to being able to restore this state to a given point in time? I don't think we would gain any value from that. And this isn't an API request, so we're not worried about caching it. So we didn't have any yes answers to this. So my inclination, and this is a personal preference, my inclination is to handle this input state in my to-do container. So we've seen this many times. We're going to pass input text down to our component. There we go. Then input text of null. This dot state dot input text. Why is this null? This shouldn't be null. Oh, this dot state. Did I set this up wrong? No. No, it should just be state. Okay, somehow this isn't working, so we're gonna just plug this back into our constructor. And I will, for you guys, I will look up the correct syntax on how to do that. Blah, whooper. Now let's move all this into here. State equals, oh, what did I have? Oh, okay. All right. Simple bug, maybe. Aha. This dot state dot input text. Okay, thank you. That works better than trying to do it the wrong way. Then in our to-do, we're going to control this with the value. And we can test that by just doing that. Okay, that is connected, that is working. Then we're going to have an on change where we're going to invoke props.handle change. Remember when this was a huge struggle and it took us 3 or 4 days to understand what was happening here, and now it's just, you guys could do this in your sleep? That same thing will happen with Redux. I promise you that. Okay, just gotta give it some time. All right, let's drop these down because it is getting to be very long. Ah, that's not what I wanted. And this is this is a function that takes an event and is going to run this dot set state, and we're going to update input text with event.target.value. And there we go. Okay, so we're at a good point to take a break, and we'll come back and we will finish the connecting pieces, and then we'll look at how to do all of this with async calls, API calls, woohoo! So I'll see you guys back. Let's go 6 minutes, 5 minutes now. Let's go top of the hour. Okay. We have this all connected up. The last piece we need to do, actually second to last piece, is our actions. Then when we finish our action, we'll come in here and we will work on a little bit more on our reducer. So in our actions directory, we're going to create an index.js file, and we're going to create a couple types. Remember how we talked about this yesterday. We're going to create a to-do or an add to-do type. Then we're going to create a toggle to-do type. Then we need an action creator for each of these types. So first we're going to create a add to-do action creator, and it's going to take in a to-do object, and it's going to return an action. So the type is going to be add to do, and the payload is going to be, so let's think about this. We could just say to do, right? But what are we really getting from our to do here? There's a few things we could do. So we're going to be invoking this, and we're going to be, when we hit a submit button out here, and all we have is this input text, right? So we're going to be passing this as a string to our add to do function. So we're going to receive a string here. So we don't want to just pass a string on as the payload. We want this to be an object like this. So let's look at our reducers, and we have value and completed. We're not going to worry about ID now. That's part of the stretch. We're just going to worry about these adding and toggling. Where's our action? There we go. So we're going to add a value, which is going to be our to-do. And we're going to always start out with completed is false. Okay, so let's bring this into our to-do container. So we'll save everything there, and we will import from, let's see, import add to do from we're going to go out of containers into the store and into actions. And then we know we add this down to this part here. Okay. So now we have our add to do. We need a way to trigger that. So let's create our button in here. And our button is going to have an on click that will invoke a function. And that function we're going to get from props. Syntax error from somewhere. Do we have everything we need out there? Yep. Oh, capitalized. There we go. Okay, so we've got our button. We need to pass an add to do function down from our container. And what is this going to invoke? We're going to create an add to do function out here. And don't need to take in anything we do, actually, because we need to prevent default. So we're going to event.prevent default, run that. And then we're going to invoke our props.addToDo right here. We're going to pass in that string that we have available right here on state. Okay, so let's see. Let's just console log right here and see our to-do. Props is not defined because it needs to be this.props. So console log, there we go. Yay, so we got our action wired up. All right. Now our action is going to, when this fires off, we know that this action is going to be dispatched. So now the last piece that we need to see is inside our reducer. So what happens when we have the case of, well, let's first import. We have add to do, and we're importing our types, and toggle to do from actions. So for the case that if we get the action with the type add to do, what are we going to do with it? And this is the important part. This is where it gets, everything that we've done up to this point, we've seen the last 2 days. I think we understand the flow really well. And I think this is one of the most difficult parts of Redux. Once you understand the flow, and like that light bulb moment happens that you get what's happening in actions, you understand what is happening with connect and map state to props. The whole idea of Redux and the data flow makes sense. So the hardest part in my mind, at least, is coming here and saying, okay, how do we, in an immutable way, return a new object, create a new object for our state. So that is really tough because it takes a lot of really good JavaScript knowledge to do that. So I'm going to look at, whenever I build a new case inside my reducer, I'm going to look at initial state, and I'm going to look at the shape of my state. And I'm going to say I need to have an object. So I need to create an object. And I know that whenever I do this inside a reducer, I'm always going to spread in the state that's passed to me. Because I'm usually only affecting one part of the state object, so I want all the rest spread in like this. Okay, so now that I have everything spread in, if we had other properties on here, then all of those would be added here, but I only need to update our to-do list. So I'm going to update our to-do list now. Spread in all the rest of state, and I'm going to update our to-do list. So how do we do this now in an immutable way? I need to create a new array that has all of my old values and my new value I'm getting with the action. I know that I have some functions that return, some array functions that return new arrays. I can't just push my new to-do onto the to-dos list because that's not immutable. So let's do this. Let's create a new array. We need to keep all the old values from here. So we're going to say we're going to spread in all the old values. We say state.todos. Now we have all the old values. Now I just need to add at the end of this list my new to-do. And that's it. If you just take that one step at a time, just look at your state, break it down, you know you have to return an object that looks like this. So just start one step at a time. Create a new object, spread in all the old values, add the property that you need to change for this action type. This property happens to be an array, so we have to create a new array, but we want to keep all the old values. And we're going to pass in the new value. Not working. Do you guys see something? I hear some Slack stuff coming through. Do's. Thank you. And there we go. Stop making, stop spelling errors. Okay, we'll just leave it. Totally did not mean to do that. Thank you for your help. That was perfect. Perfect timing for that. I think I saw someone say, let's see, that you did not do it differently. That's totally fine. There's a lot of ways to get to this point. In my mind, this is the easiest way to look at it and understand what's going on. So I like to do this. Tom showed us how to do it with object.assign. That is a really great way to do it. So yeah, lots of different ways. Okay. Cool. Yeah. Again, so many different ways you could handle all of this. And as long as it's working, you're probably okay, as long as you're not doing anything really, really out of the ordinary. So really quick, we're just going to do our toggle. This will go really fast. So let's start from our view, and let's say every time we click on an LI, we are going to invoke props.toggle to do. So we need toggle to do from our container passed down. And we're going to say this dot toggle to do, toggle to do, event, okay, so one thing we need to do with this is we need to know which to do we're toggling, right? So there's a cool way we can do that. Inside our map, in our to-do list component, our presentational component, we're going to pass in the index. We could do this with IDs if we had built-in IDs, but we're going to pass in our index into our map. And when we, let's see if we can make this a little bit easier to see. So let's wrap all of this inside that. And we'll drop this down and that. Okay. All right, so there we go. Inside our LI, when we click on this, we're going to pass in the index of the to-do that we're clicking on. So we put this in an anonymous function because we don't want that infinite loop situation happening. Okay, perfect. So now when we invoke toggle to do, we are receiving the index of the to-do we want. So we need an action for this. So we'll say export const toggle to do is going to receive an index, and it is going to return an action with the type toggle. That's not what I wanted. Toggle to do and a payload of the index. And that's it for that one. So we need to bring this, import this into our container right here. And we need to pass it into our connect right there. And then right here, we now have it available to us on this dot props. And we simply invoke it with our index. So if we console log that, make sure it's working, and we click on that, we get the index. Woohoo! Perfect. Oh, we took away our ID. Okay, so the last thing now is the reducer for this one. This reducer is a little bit more complicated. And why is that? Instead of just recreating new things and spreading in and then tagging something at the end, we actually need to change one of our objects in here. And doing that in an immutable way is tough. But this is where we're going to use a really cool function called .map. So we're going to go off this basic same idea here where we're creating a new array passing in our state, but this time for our to-dos, we're not adding something, we're just looking at everything that's inside this array, and we just need to find one to-do, the to-do that we clicked on, and toggle its completed property. So if we do state.todos.map, we know we're going to have a new array created for us from the map function. So this is immutable. We're going to pass in each to-do and the index of each to-do, and we're going to say return. We're going to do a couple different things. So we need to add curly braces. So to make this a little bit more legible, we'll drop these down. We'll drop that down. There we go. If the index equals our action.payload, which remember is the index of the one we clicked on, then we're going to return our to-do. We're going to return an object into our array. And this object will be we're going to spread in our old to-do object. So we're looking at these one at a time, right? So we're going to spread in this whole object, and then we're going to toggle the completed value like that. So let's take a look at this. If we're on the first iteration, if we're looking at this to-do right here, and we see that the index value is 0, and we had clicked on this to-do, then our action.payload would be 0. So these would both be 0, and we would hit this line here. So what is this line doing? Well, map is going to go through each item one at a time, and it's going to return something into a new array and build a new array for each element in this array that it's mapping over. So we need to build a new object for this case here. So we're looking at to-dos at 0, which is this to-do here. We spread in the whole thing, and then we override the completed property with the toggled completed property there. If it doesn't equal, if these are not equal, then we simply return the to-do. Oh, but we need to return that. So it's a little more complicated here, but we're still building a new array, spreading in all of our old state, and then we're going to override our to-dos list with a new array from .map, and our .map is going to look at every single item in the to-do list, and on the one item that we clicked on, it's going to build a new object for that item by copying the old object and replacing the completed value with the toggled completed value, with the opposite value. So let's take a look. We need to open this up here so we can see this happen in state. So our to-do list, we have our to-do list here. If we click on walk the dog, then you see that it's completed, has been set to true, and false, and true, and false. So now we have 2, both are false. We can look at our Redux tools. Maybe we have to reload. So we added to do. we toggle it to do, we can see the difference right here. It went from false to true. We can watch our state change. So this is the state for our entire application right now. We can look at the chart of our state, hover over that and see what each value is, or even look at the raw tree that we have built through these different interactions. So there we go. I'm sure there's lots of discussion happening, so we'll take a look at this. Let's see. Yeah. Thank you for pointing that out, Brian. You will see object.assign a lot out in the wild, out in the world, but a lot more people are actually moving to the spread operator. It just is a lot cleaner. Let's see. Is .map, .filter, and .reduce our only option as far as immutability? Nope, thank you, Brian, again. .slice and .concat are good, but .map and .filter and .reduce, again, just make things look a lot simpler on the screen and are a lot easier to kind of reason about our data. So I highly suggest getting good at using these filters or functions over these ones. I was looking at .filter when I said that. Let's see, this is really good. Yes, I highly recommend this. Cool. Okay, so let's take one more break and then we will look at Redux Thunk. It won't take very long to learn Redux Thunk. There's just one small change that we'll make with our application here, or with our entire Redux flow. So take a 5-minute, take a 5-er, and we will jump into that. Okay. So now that we have half an hour left, let's go into today's lesson. Woohoo! All right. We will jump out of here. So again, this whole part is for today and tomorrow. So we're going to briefly discuss the finite state machine pattern, and then we will use Redux Thunk and apply middleware into our project. Give me 1 second, because there's obviously some loud boys outside my door. Okay. Calling in the cavalry. All right, so finite state machine pattern. Does anybody know what the finite state machine is? What a finite state machine is? This isn't necessarily a developer programming paradigm. This is actually something more in the mathematical world. But has anybody heard of the finite state machine? Good. I don't know what any of that means. While you guys are typing, I'm going to start talking about it. So it basically, yeah, it's basically some mathy wombo jumbo. So if you think about this, actually happens in nature a lot around us, and you'll start to notice this now after we talk about this. But the finite state machine pattern means that if you have something that can be described as a finite state, it means it has a finite number of states that it can be in, and it can only be in one state at a time. So I really like the example of a car. A car is a finite state machine. It has a limited amount of states that it could possibly be in, and it can only be in one state at a time. For example, a car parked in a driveway is in the parked state. And it's not moving. We'll say that our car is turned off, so the state of our car is it's parked, turned off, not moving. If we get in the car and turn it on, it is now in a new state. It is turned on, idling, and still not moving. You put it in reverse and you start backing out of your driveway. Your car is turned on, it is moving backwards, and it's in gear and it's moving backwards. Then you put it in drive and you start driving forward. Your car is moving forward, it's turned on, it's in gear. You can come to a stop sign, it's turned on, in gear, but not moving. So you can see that really soon we're going to run out of different states that this car can be in. And it can only be in one state at a time. So that's the idea of a finite state machine. And developers have liked to kind of compare web applications to finite state machines. I'm just going to stop looking at this because I have no idea what's going on. You guys have gone way over my head at this point. So let's look at Facebook, and hopefully my feed is clean today. Memories, cool. We built a bunch of shirts one day. Yay, that was fun. Okay, so I'm going to go to Marketplace. When I click on Marketplace, the Marketplace single page application is going to be in, it's going to quickly go through a couple different states before it finally gets to a state where it's full of data and waiting for an action. So those states that it's going to go through is empty, then it's going to go to empty with data being fetched, then it's going to go into that final state where the data has been fetched and it is showing all the data and waiting for a new action. Okay, so we saw that happen. It was very, very quick, but we saw it happen. Let's click on one of these and watch for it again. You'll see the spinner bar, so everything's empty, and milliseconds after that empty state, we're going to go into a new state where it's empty, but there is now an API fetch happening. And then that API fetch will come back and bring data back, and we will go into a new state of not empty. We have data, and we're rendering that data. Ooh, this group one is a really good one because we see that empty state with the spinner, and then we see data right here. You'll see data is being fetched by these gray lines right there. Let's do it again. So in that brief half a second, we can see 3 different states being rendered onto our page. Now, when we start building out applications, we want to make sure our users know that we are fetching data with some indicator, like the spinner bar, like these silver lines, these gray lines that keep showing up here. When we're in an empty state, whether we're fetching data or not, we need to tell our users, inform our users what is happening. Usually what is happening is we're making an API call. Please be patient, we'll be right back with some data, and then we'll fill up your page with data. And Facebook does so good at this with those spinners and with these gray bars, loading bars here. So I want you to keep that in mind as you continue to build out your applications, especially now that you'll be using APIs and doing async calls that take time for those calls to come back with data. Okay, so what we're going to do is we're going to look at this application here. It's probably going to be broken. It's not going to work right now, and that's okay. So we're going to learn about, in our Redux flow, how do we make asynchronous calls? Right now, before we learn this today, everything we've done up to this point, Redux has been synchronous, and so if we tried to make an async call to an API, we would be stuck until that API call returned, and we wouldn't have any way to for our application to continue executing code in an asynchronous manner. So for this, we're going to use, to turn it to give it the ability to do async, we're going to use Redux Thunk, this library here. So you'll have to go into your dependencies, or you'll have to yarn add Redux Thunk, and then we'll look at briefly what Redux Logger is as well. So Redux Thunk is a Redux middleware. Middleware is a powerful extension point for Redux. Basically, it adds new functionality to Redux. So middleware within Redux lets us add new functionality like making asynchronous calls. When we add middleware to our Redux store, a couple things could happen. This middleware is going to intercept every action before it flows through to the reducers. And we can stop actions, we can forward an action untouched, we can dispatch a different action, that seems useful. We can dispatch multiple actions. There's lots that we can do with middleware in Redux. Here's a pretty good flow chart for the difference between Redux without middleware and Redux with middleware. Without middleware, our component calls an action creator, which returns an action that's dispatched to all our reducers, and it updates our state. And then our state sends those changes to our component, and it starts again. So we've seen this flow. We feel pretty good at this point with what's happening here. Middleware is going to jump in right here before actions are dispatched to the reducers. So our component will call an action creator, which returns an action that's going to flow through all the middleware, and then it's going to be dispatched to reducers once we tell it to. Once it gets to reducers, it updates state, and our component updates. So let's look at Redux Thunk. Redux Thunk makes it possible for us in our action creators, instead of returning a single action, we're now going to return a function. And this function is going to have access to dispatch. So let's take a look at this. We're going to build this out, and we are going to we're going to learn how to do this inside our application with our Redux Dogs app right here. So to get started with Redux Thunk, we import Thunk from Redux Thunk, and we import apply middleware from Redux. Then in our create store, we're going to pass a second argument to create store. And this argument is going to be apply middleware. Apply middleware is a function that all we have to do is pass in the middleware that we want to use inside Redux. And that's it. That's all the wiring up you have to do. Import it, import apply middleware, pass it into create store. Redux takes care of the rest. So what does this mean for our project, for our apps? In app.js, you see that we have props.dogs being passed to us from our state. We also have error being passed from Redux, and this fetching dogs idea. If you look at these describe the different states for the finite state machine. Here, our app is a finite state machine, and this kind of describes the different states. So we're going to tell our Redux store if we're currently fetching data. We're going to tell our Redux store if we have data and we're no longer fetching, or we're going to tell our Redux store if we have an error from our API call. And then our Redux store will inform our component about all these things, and it will say, and then our component will make a decision. Well, if we're fetching dogs, then we're going to display this H3 header here. Hold tight, we're fetching your dogs. If we're not fetching dogs, then we're going to display our dogs in here. If there's an error, then we will display the error in this H4 header here. Otherwise, that will render nothing. So as you're we are going to kick off we're going to invoke this fetch dogs action creator. Okay, we have a fetch dogs action creator. This is going to have an asynchronous code inside of it. So we are going to invoke that from component did mount, just like we would with hard-coded data, just like we would if we weren't using Redux. We would put the async call right here. With Redux, we still invoke that from component did mount, but now it's the async code is put inside our action. So let's take a look at our action. We've got Axios, we've got our types, a type of fetching dog, dog fetch success, and dog fetch error. So these three types above are all a representation of our state machine. Fetching, resolve, reject, etc. Start to notice this pattern. You'll use it constantly in Redux. So let's do some async code inside our action creator. We ready for this? All right. I'm ready. So remember I told you that instead of returning an object, React Thunk, way too many close sounding words. React Thunk lets us return a function. But we can write this a little bit cleaner with an arrow function. So let's make an anonymous arrow function that takes in dispatch, the dispatch function as a parameter. There we go. So we're going to return a function, and we're going to, inside this function, very first thing we're going to do is dispatch our fetching dogs. So our fetch dogs action creator only gets invoked when we want to make an async call, make an API call to fetch our dogs. So we're going to tell our app that we are currently fetching dogs. So we're first going to dispatch, and we're going to pass in an action here, because we know the dispatch function takes in an action, right? We're going to say type is fetching dogs. We don't need a payload because it's just going to flip a Boolean for us. So let's take a look at that. Dogs reducer for the case fetching dogs. Here's our initial state. We've got dogs as an empty array. Fetching dogs is false, and there's no error. So here's some object.assign syntax. We're going to keep jumping back and forth so you guys get used to seeing it all different ways. If we're fetching dogs, then all we're doing is changing our fetching dogs to true. Okay, so let's take a look at what that does for our app. Oh, snap. Hold tight, we're fetching your dogs. Cool, so that worked. That dispatched an action and changed our, if you remember, in our component here, if fetching dogs, this.props.fetching dogs is true, we're going to render this right here. So we changed it to true, and now we're rendering this. Okay, so now let's actually, we've told our users we're about to fetch your dogs. Let's actually run an Axios. There we go. And today is going to be Husky images. Okay, so we know that this is a returns a promise, so we can .then and .catch off of this. There we go. And we have a response, and we're going to do something when we get that response in. If we get an error here, we're going to do something more than just console log our error like we've done in the past. So if we get a response, we want to dispatch a new action, right? And the type is going to be our success type. And now we're going to have a payload. So let's take a look at our reducer and see what we're expecting for our payload. Okay, dog fetch success. We're object assigning a new object, filling it with all of our state, and we want to replace dogs with all of our old dogs and action.payload. So this action, this here, needs to be the array of doggos, because we are just spreading in our array of doggos here. So in order to know what this is, how to get that from our response, we'll quickly console log our response. Okay, so we have response.data.message. So that's what we're going to pass in to our dispatch. Payload is going to be response.data.message. Now we are we can see it happening. Now when this is successful, we're going to dispatch a new action that's going to take in, that's going to be the type success, and it's going to pass our reducer a payload that's an array of images. Now, the other cool part here, you may have noticed this, is after we replace the dogs array with our payload, we're also changing fetching dogs back to false. So we don't want to display that message anymore. We'd rather display our data. So as soon as the success happens, we're changing fetching dogs to false. And same thing with an error. If an error happens, we're no longer making an API call, right? We have an error, but we're no longer fetching data. So when we get an error, we're also changing fetching dogs to false. So let's handle this error situation. Doesn't look like we need a payload. We're just changing fetching dogs, and we're saying some error happened. So if we have an error, let's dispatch new action with the type dog fetching error. We'd like to know what the error is, so we'll console.log the error here. And that's it. We're just combining dispatch. We're just combining two principles that we know, two things we've learned. We've learned about Axios and how to make API calls, and we know about the dispatch function that we pass dispatch an action, and it will invoke our dog reducer with that action. And that's as simple as it is. That is Redux Thunk. A cool way that we could write this is, watch this. We could, let's get rid of this. We could do this. Oh, that's neat. And that's valid syntax there. I'm just going to copy that, step back, and we'll keep that the same, and then I'll put it down here and comment that out so you can see this way of doing it as well. So this way is a function that returns a function. Or, in other words, a function that returns a function. So you can do it either way. All right, we also saw that in our index.js that we have this logger middleware that we got from Redux Logger. So let's do this and see what Logger does for us. We don't have to do anything to set up Logger. We just simply put Logger right there and watch what happens. Oh, this is no longer, we're no longer in this one. Ooh, look at these console logs. Huh, interesting. So Logger is basically going to console log every single action that happens, every single action that gets triggered, and it tells us our previous state. It gives us the action. We were fetching dogs, and then it gives us the new state. So before we dispatch the action fetching dogs was false, and then after we did that, fetching dogs was true. And then we sent the action dog fetch success. So before we were at true and no dogs, we sent in the dog fetch success action with a payload of 192 images. And so our next state, we set fetching dogs to false, and we have 192 huskies right here. They're so cute. Okay, I would get a husky. If anybody has any secret knowledge of huskies that you want to warn me about getting a husky, please let me know, because this is one pet I would have. Cool. Any questions with all this cool stuff? Still talking about, okay. So the function that dog action returns is our middleware. Ooh, good question. The function that returns is we're able to return a function here because of our middleware. It's not necessarily the middleware itself, but Redux Thunk lets us do this instead of returning an action. What if we want to load all the images at once? How would we go about doing that? Husky shit. Oh, really? Okay. All right, no huskies then. What if we want to load all the images at once? That's what we're doing. Do you have, can you clarify that question a little bit? We do load them all at once. Oh, what if we didn't want to load them all at once? Then you'd have to handle that if you wanted to, I don't know, use a set timeout and every half a second add 10 more dogs. Then you would, inside your response right here, dispatch an action with the first 10 dogs, wait 10 seconds, dispatch an action with the next 10 dogs, wait 10 seconds, or half a second, not 10 seconds, dispatch the next 10 dogs, something like that. You don't have to send the entire array as your payload. You can split that up. Okay, I'll look at all the husky feedback later. Looks like those, oh, here we go. So by definition, what and where is our middleware here? Good question. So inside of our create store function, the create store function is going to invoke this function here, and inside apply middleware. That's where our middleware live and do its thing. So basically, when we invoke an action creator from our component, so when we do this, Redux takes over at this point, right? We've seen that, we walked through the code. Redux takes over, and it will our component invokes our action creator, and our action creator will still return an action, but that happens behind the scenes, and that is going to flow through our middleware. Actually, I think that's wrong. I think this needs to happen after the middleware. So our action creator gets invoked, and the middleware, Redux is going to say, oh, I've got some middleware I need to apply here. It is going to hijack this flow and run everything through the middleware. So instead of, remember when we did the walkthrough of the behind the scenes stuff and we got to our action creator, and we saw that when we return an action, that it was, Redux was invoking dispatch with that action. Redux Thunk stops that and says, nope, we're not going to do that. And so we can return a function, and it will invoke this anonymous function. Redux Thunk invokes this anonymous function and passes the dispatch function to it, so that we manually now are dispatching our actions. And we want to do it manually because we want to control when we're fetching dogs. We want to wait for Axios to finish and before we get a response, and then manually dispatch success or error. So we don't really see the hijacking process here. This is, you can go look at Redux Thunk and look at the source code and try and figure out how it's doing that. We don't really have time in this class to step through like we did with Redux. We just have to kind of trust the process that Redux Thunk is hijacking it at this point and is invoking this function and passing in dispatch. So now we have the ability to dispatch multiple actions inside this single action creator. So I know that's not the answer you're looking for. I do apologize. But yeah, Axios, so we wouldn't be able to do this inside a normal action creator. We wouldn't be able to do an async call inside a normal action creator. So Axios is controlling the async flow, and Redux Thunk is letting us even do async things within Redux. Okay, if there's any other questions, let me know. So I a little bit more after lunch. Cool, so let's take a look at our project. Our project today is Redux Swappy, and then tomorrow is Redux Friends. So today we have a lot of the stuff built out for you here. You need to add the dependencies. We haven't added the dependencies yet. Add those and then put them where they go here. The component is pretty well built out for you. So we're already mapping, here we go. We're already mapping the characters. We've already told your component to check for fetching. And if it's fetching, display an image. If it's when we're done fetching, display characters. So your responsibility in here is to pull in actions, create map dispatch to prop function, and then add the map dispatch to props function here. So you'll replace null with match dispatch to props, and then your actions will go inside this object. Then you can call your action creator here inside component invent. This is just importing and exporting the app for you. So don't worry about index. We'll talk about this tomorrow. I was hoping to get it to it today, but we didn't. So we'll talk about index.js and why there's so many index.js files everywhere and why it's actually a good thing. So actions. You've got your action here that you will need to create. So we'll need Axios, and then you'll create three different action types, like we did with the doggos, and then the action creator, like we did with doggos, and here is your endpoint. And then the reducer is already returning your initial state. We don't have initial state yet, so define your initial state here. It's going to be very similar to our initial state in our dogs reducer, where we've got something that's fetching a Boolean for whether or not we're fetching things, an error string, and some array that will be filled with our data. And then fill out with the important reducers, reducer action types, excuse me. So we should have a fetching, a fetched, and an error. And that's about it. Yeah, that covered the project there. In the README, you'll notice that, I don't know why this is set up this way, but it basically goes through like, so you initialize the project and then it basically goes through the lesson again. So you can read through all of this. And it basically talks about what we covered the last half an hour of class. But if you go down to the bottom, this is the important part. This is the project and the steps here. Okay, there we go. We are now async. Hopefully, we took a long time to do our walkthrough today, and I recognize that you guys did that in after hours yesterday. I know that not everybody can make it to after hours, so hopefully that helped those who weren't there. And just one more pass on all of this, I think is helpful and good, and repetition, repetition, repetition. So yeah, again, if you get stuck on anything, work on it for 20 minutes, then reach out in the help channel and help each other out, guys. I see a few of you helping fellow students out in the help channel, but a lot of times it's project managers jumping in and answering questions. I'd love to see more. I'd love to see you guys helping out your peers a little bit more there. Code, what is it? The next step after the help channel is I cannot think of the word, where you paired programming. Then reach out to your PMs at that point. You should be about 40 minutes into your problem before you're really reaching out to your PMs or myself. So remember that flow, and yeah, good luck today. We'll chat one more time tomorrow before tomorrow's going to be our last lesson together. So we'll see you guys tomorrow morning.